Okay, so I think I am live. Am I live? Obviously, I am live. Okay, should I wait till a little bit of like some guys join, or should I start with the video? Tell me, guys, tell me. Wait, let me do one thing. I'll just put the link on Discord, okay, and then start with it. Okay, so today the lag is also quite less. It's a good thing. Okay. Anyways, I think that not much people give Codechef these days. Okay, I think till people join, we can start with the problems. Okay, because I won't be explaining that much of codes today. Because I think today's contest was kind of a good one. Am I getting any positive delta though? I don't know. A little bit of positive delta, not good. 1932. Actually, the fact is that this problem only 5 people did, and I had a lot of bugs on this problem. Can't help. Okay, so let's start with the first question. Okay, make scene. You're given three binary strings s1, s2, s3, each of length n. Your goal is to make. I need some guidance from you for my placements. Okay, what do you need? What do you want to know? Like, if you want to know about how to get into some companies, like I think mostly they focus on DSA and a little bit on development. Like a very small part of development is needed. Like if you're good with your DSA skills, if you're good with problem solving skills, and because in most of the companies they ask an I jth index of s of y. Okay, what do I mean? You're given three strings. As I am from somewhere, not a single company with it. See, just a minute. See, the thing is that like if if neither of a company visits at your college, I get it. This is a problem with a lot of people. Even I face this problem. Okay, even in my college, also not much companies visit. But I was lucky enough to get a company like it visited. Okay, if you have a good resume, apply for off-campus drives. Okay, 5 months left. What would you suggest me to do in this time? If you've got 5 months left, go with your DSA. Just nail it. Just nail your DSA skills. Okay, just work on them. Okay, well, so you're basically given three strings. I'll just discuss about this after the explanation of the problems. Okay, you're given three strings. All the strings are binary strings. Okay, that is, it is consisting of numbers 1 and 0, and you have to make all the numbers as same. Okay, You have to make all the numbers same. Now this is just an example that I am showing you. It is not perfectly what your question should be. Now since you know that in every string you have to make all of them same. Okay. So what does that mean? It basically means nothing but the fact that you have to either make all of them. Yeah, you'll text on Discord. Yeah, it works. So you have to either make all of the numbers as 0 or all of the numbers as 1, right? So it was also given in the question that we can either print -1 if you find that it is not possible to make it, or print like the number of operations that we have to do. Okay. So basically, since we know that we can number of 0 mod n is equal to 0, number of 0 mod n is equal to, yeah, both ways it works. Number of 0 mod n, number of 1 mod n, both works. Okay. Now see, why is it number of 0 mod n? Because it means that if I'm having it in this manner, okay, just consider this to be in this manner, in a three row pattern, okay, which means that every row is going to consist either of 0 or 1, right? So what is the total number of ones? It can be like either the first row is completely filled with 1, the second row is completely filled with 1, the third row is completely filled with 1. Okay, this is one of the conditions, that is all the three rows are 1. Another condition, any two of the rows are 1. Another condition, any one of the rows is 1, because the remaining two is completely 0. Another condition, none of them is 1. Okay, so in all the four cases we know one thing, that the number of ones mod n is equal to 0, because 1 fills up n elements either 0 times or 1 time or 2 time or 3 time. Okay, so this is the condition that you have to understand. Number of 0 mod n is equal to 0, or number of, oh sorry, or number of 1 mod n is equal to 0. Okay, clear? Now since we have done that condition, now we know that okay, we are good to go with it, which comes to the next conclusion, that is, if it is satisfying, that means it's not a -1. If it is not satisfying, it's a -1 directly. Now if it is satisfying, what do we need to do? We have to consider what is the minimum number of operations that we have to perform, right? So what is the minimum number of operations? Let's say if I am having that all of the elements are 0, that is all of the rows are going to be 0. So that is well and good enough. I don't need to do any operation only. So the case 1, okay. What is case 1? Case 1 is nothing but everything is 0. Everything is 0, okay. Or case 1 may also mean that everything is 1. Okay, everything is 1. So either ways, case 1 satisfies, which means that I have to know, I don't have to perform any operation only. Okay, I'm good to go with it. So number of operation over here is 0. Okay, let's move on to the next case. Case 2. Okay, what is case 2? Case 2 is that two of the rows are going to be 1. Okay, any two of the rows. I don't know which two rows. Let's say this row and this row is going to be all ones, and the last row is going to be all zeros. Or maybe the first row and the last row is going to be all ones and the second row is going to be all zeros. Okay, so in that case, what do we need to do? Since we know that any one row is going to be all zeros, so what we basically need to do is we have to replace all the ones in that with some zeros from some other place. So we have to find how many ones are in those rows. So what is the best approach to do? Like, since in this case, like if you're putting ones in the first two rows, which means that we are left with the last row which we are going to put zeros. Okay, or we could have done it like this also. This and this is red and this is blue. Okay, blue means 0 and red means 1. We could have done it also like that, or we could have done it like red, red and blue on the top. Okay, that also works. So any three of them works. Now since any three of them works, what we have to do is we can check like which one should be the blue. The blue one should be the element which will be consisting of all zeros like after the operation, right? Now since I have to make it all zero, so I have to find the row which has the maximum number of zeros. Because if it is having the maximum of its element as zeros only, so if to make it all zeros it will require lesser number of operations, right? Because if we are rearranging only one specific row and making it satisfiable, then the other two rows are going to be automatically rearranged. Okay, are you guys getting it? Yes or no? Yes or no? Okay. So for the blue, what we have to do is basically nothing but check the number of zeros in it, check the number of ones in it, because we have to replace the ones, right? Check the number of ones in it, check the number of ones in this, check the number of ones in this. Whichever is going to give you the minimum one, that is the answer, right? This is the case 2. What is case 2? Case 2 means that there are two n number of ones and one n number of zeros. Okay, because two rows are 1 and one row is 0. What is case 3? The opposite. It is just the opposite. Two rows are blue and one row is red. Okay, okay, sorry. This is case 3. Okay, now in this case also the same thing, just the opposite thing. That is, previously we were counting the number of ones in it, now we are going to count the number of zeros in it. Okay, you do all these operations, get your answer, that is the answer, print it down. Okay, any doubt? Yes or no? I'll explain you with the code. See what we do. We are going to first of all, no doubt. Okay, great. No doubt, right? Or is it not clear? Like write it properly, no doubt. Or let's write it clear. Okay, so it will be better for me to understand. No doubt. Okay. So what I do is I find out the number of ones in it. Okay, and if I find that the number of ones is not equal to 0, so I can return -1 directly. Otherwise, I can check like which case I have to satisfy. Okay, this is the case 1. Okay, that is either the number of ones is all of them are 1 or none of them are 1. Case 1, well to good, no operation needed. Case 2, we have to find out for every specific row what is the number of ones, and we have to find out the minimum of them. Okay, for every row we find out the number of ones and find out the minimum of them, and at the end we print 1. What is the case 2? Case 2 is there are two rows which are going to be 1. Okay, and case 3 is only one row is there which is 1, that is the else part. So this is also we are going to do the same thing, but over here we are finding what is the maximum number of 1 in every one of them, so that we know that since n is equal like number of zeros is equal to n minus number of ones, now since we have to minimize the number of zeros, so we are going to maximize the number of ones. The same thing apart from the fact that I'm going to go with n minus 1. Okay, but this is a common part. Okay, this is a common part in both of them. I did this just purposefully to make you guys understand, because initially I was doing this as I was finding the number of zeros over here instead of finding the number of ones. But if you notice this thing, this is the number of ones, right? But something different from the previous one and this one is, initially we were finding what is the minimum number of them, and now we are finding what is the maximum number of them, right? So instead of doing all these amount of codes, since we know initially that yeah, we are going to have only 3 strings, so we can find the number of ones for all the 3 of them, and then find the maximum, the minimum for this, and n minus the maximum for this. Okay, we could have also done it like n minus maximum 1. Okay, and this will be maximum 1. Okay, is it clear? I hope it is clear. Let's move on to the next problem. Alternate it. Given a binary string, you can perform a series of operation on it any number of times. On the first operation, you can shuffle any substring of s in any order. In the second operation, you can choose any possible substring and flip every bit of it. In the third operation, you do the first operation. In the fourth operation, you do the second operation. Fifth operation, first operation. Sixth operation, second operation. Find the minimum number of operations to make the string completely alternating. What do we mean by alternating? Alternating means that zeros and ones occur at alternate positions. Okay, it is somewhat like this. One off-topic question: how to identify a greedy problem? Mm, greedy problem. Even I can't tell. Okay, so alternative means that it is going to be like this: 0 1 0 1 0 1. Okay, I hope you guys know about it. Now, since we have to make it alternating, and in the first case, what we can do is, so we are going to generally go with this condition that we are going to make it like as small as possible. Okay, because if it is already alternating, do one check if the sequence is alternating or not, that is the previous element for every one of them is different or not. Okay, if any one of them occurs to be same, so it is not alternating. So if it is already alternating, you need to do 0 operations. Okay, well and good enough. Now if the number of zeros and the number of ones differ by at most 1, which means like in this case, in the thing that I have drawn over here. Okay, so this is also alternating, this is also alternating, right? This is also alternating, this is also alternating, which means in this you can find that the number of zeros and the number of ones are same, but in this you will find that the number of ones is 1 greater than the number of zeros, which comes to a conclusion that if the number of zeros is 1 greater than the number of 1 greater than the number of 1, or the number of ones is 1 greater than the number of zeros, so we can rearrange the whole string and make it alternating. Are you okay with this? Any doubt? Guys, just respond like if you're not okay, tell no. Okay, just tell. Okay, continue, bro. Got it. Okay, great. I was doing that operation for ones is equal to 0. No, no, no. Even for one more than one, it is okay. Okay. So we have got 2 cases till now. Okay. Case one, it is already alternating. Print 0. Case two, if we rearrange the whole thing, that is the absolute value of 0 minus 1. Okay. It is lesser than equal to 1. The case that I just explained. In this case, it is going to be 1. Okay. Previous case 0, this case 1. Case 3, that is we have to target 2, right? We have to do it in 2 operations. How can we do it in 2 operations is our question. Now see, This case 3 is a modification of case 2. Let's say we had it like this, okay, the same pattern 1 0 1 0 1, right? Okay, it didn't get. Okay, 1 0 1 0 1. So in this case, we find that this is an alternating thing. Why? Because the number of ones and the number of zeros differ by at most 1. Okay, this will go to case 2. But the moment we add an extra 1, it becomes case 3. Because even after rearranging, you have to flip one of them. Okay, you have to flip one of them. Basically, you have to flip this to 0. Okay, so case 3 is when it is lesser than equal to, how many ones are there? 1, 2, 3, 4. 4 ones and 2 zeros, right? So if it is lesser than equal to 2, over here we were going for lesser than equal to 1. Now if it is lesser than equal to 2, it is 2, right? But what if it is lesser than equal to 3? Can we still make it 2? Because now comes the a little bit advanced knowledge, okay? Can we still make it 2? Let's say if it was 1 0 1 0 1 1 1, can we still make it 2? What can we do is over here, you have to understand this, okay? This looks like 1 0 1 0 1 1 1. What if I did it like this? 1 0 1 1 1 0 1. Works? How many are there? What is the difference? It is 3, right? Because there are 1 2 3 4 5 ones and 2 zeros. It is 3. But if we flip this, it is flipped. So even for 3 we have done it. So we can go on till 3. Okay. Sorry. We can go on till 3. Okay. Can we go on till 4? Well, we can't. Okay. You don't have to check it, but we can't. Okay. Exactly. We can't go on till 4. Now comes the case 4. Right? Case 4. So whenever we find it that it is 4, we have to go for 3. Right? We need 3 operation. So if it is 5, can we still go for 4? Can we still go for 3? That is the question. But what if I told you that 3 is the maximum number of operations that you will need to do? Within 3 operations, you can do anything that you feel like. Why so? Let's say you don't know how many number of zeros are there, how many number of ones are there. Okay. Let's say if you've got some number of zeros and some number of ones. So what if you rearrange it? In the first step, you rearrange it like this: 0 0 0 1 1 1 1 1. Okay. After rearranging, let's say we have to make this absolute value. In the next step, what we were going to do it, we have to make it absolute value lesser than equal to 0, lesser than equal to 1, right? Which means that there are 3 zeros and 1 2 3 4 5 6. Okay, no, I think we will go with more ones. Okay, to make it more complicated. With top 2 operations, we can absolute of ones. Yeah, exactly. I just mistook it. This is the new case. Okay, there are a lot of number of ones. Okay, so this thing you can't do with 2 operations. Now you will be needing 3 operations, right? Can you do it in 3 operations? Because I just told that this is the maximum number of operations. 3 is the maximum number of operations you will be needing. How? Since now find out how many elements are over here. Okay, it is 1 2 3 4 5 6 7 8 9 10 11 12 13. 13 elements. And it's the best approach in alternating sequence to divide the zeros and ones into 2 parts. That is, the number of ones and number of zeros should be like n by 2 and n by 2. At least we can have one extra, right? So in the first operation, we rearrange it like this. We sort all the elements. First operation done. In the second operation, what is 13 by 2? It is 6. So we make 6 zeros. That is, this subarray we take and flip it. 1, 2, 3, 4, 5, 6, 7. Done. We have flipped it. In the third operation, rearrange this in 101010 format, okay? And you will get it. So in 3 operations, you can get it. Is it clear? If you want me to go through the code, I'll go through the code quickly. I'm finding if it is alternative or not, okay? So if s of I is equal to s of I minus 1, alternating is 0, which means that if any two elements are same consecutively, so it's not an alternating. So if it is alternating, it is 0, case 1. For every one, I am going to go for 1 plus plus and 0 plus plus else, okay? If it is having lesser than equal to 1, it is 1. Lesser than equal to 3, it is 2, otherwise it is 3. Got it, got it, got it. So you guys are excited for the next problem, multiplexer. Should I move on to multiplexer? Anyone has got any doubt? Both use same variable name. What variable name? Yeah, 1 0. Okay, okay. No, man. Like, if you know that we haven't copied each other's code, then why would you have that? Alt also, I get it, I get it. It's okay. Well, multiplexer is a good question. It is a worthy question, okay. I won't go through the question. Okay, I'll just read out the question and then I'll explain what it means. You're given an array A of length n and a positive integer x. You're allowed to perform the following operation at most once. Choose any contiguous subarray A and multiply each element of the subarray by x. Your task is to determine the maximum possible frequency of any element in the array after the operation is performed at most once. The frequency of an element is defined as the number of times it appears in the array. Okay. What does it mean? It means you're given an array. You're given a number x. You can choose any subarray and multiply every element with x. Okay. This is, let's say, x. And multiply every element with x. And after you're done with the multiplication, you have to maximize the frequency of any of the elements in it. Okay. Anyone did this question? First of all, tell me. It's just a yes or no. Okay. Simple yes or no. No. Okay. Great. How many of you have heard? Okay, came for this question. How many of you have heard about Kadane's algorithm? I think, yeah, it's I don't know what it's pronounced as. It's Kadane or Kadane's algorithm. Okay, this subarray. Yeah, subarray. You heard about it? You know what does it do? It basically does nothing but, let's say if the array is having some negative numbers also for max subarray. Yeah, right, exactly. For max subarray. Whatever I am going to explain you now at this moment is just an advanced version of Kadani's algorithm or minimum subarray also. Right, you're right. Kadani's algorithm tells us that at any position, whenever you find that the sum is lesser than 0, you replace it with 0 because you know that you don't need that part only, right? What if I told you at this moment that what is the position that you have to consider the subarray from? It is Kadani's algorithm. Understand this, okay? This is a very, very interesting question. Very interesting question. I think there were quite a number of submissions for this, 541. I don't know how come so many people came up with this, but this one was a very interesting question. See, let's come up with some example. I think this question will be well explained with some examples. Okay, 10, 2, 8, 2, 4. Well, 10, 2, 8, 2, 4. What is the value of x over here? The value of x is 5. Okay. First of all, what we encounter first? 10. Okay. Well, I don't know what we have to do initially, right? I get 10. I'm happy with it. I keep it. I keep the 10 with me. Then I encounter 2, right? But the moment I encounter 2, do I find that there is a pattern that instead of keeping this as 2, if I multiply this 5 with this 2, this becomes 10 and it is going to contribute to this, right? So let's say initially I make it contribute to it. So initially I make it 10. Now there is this 8. But there is also a 2 after it. So even this can contribute to the 10, right? Even this can contribute to the 10. So I make it contribute 2. Okay. So whenever I find that, yeah, 2 into 5 is like x into 5 is 10, I make it contribute. If it was somewhat else, like we would have done it like that. Okay. Now, since I have concluded, like I have done that operation to that, this 10 and this 10. So I have to consider all the elements in between that also. So I have to make this also 40. Okay. This is a good approach. We are done with the solution, right? We have come up with the solution. Are you guys happy with the solution? Like, is this a solution? This is the solution. Like, yeah, this is the solution. But are you guys happy with the logic that I just told you? That whenever you find that if that x into 5 is equal to 10, like you're going to do it. That whenever 2 into 5 is equal to 10, just do it. This is not a good solution, right? This is not a good solution that you will come up with. Why so? I'll explain it. Instead of having 10, 2, 8, 2 in this manner, what if we had 10 to 10, 10 to 10. Exactly. 10 to 10, 10 to. Okay. So in this case, or rather say 10, 10, again a 2. Okay. So if we are not doing any operation only, what is the number of tens? 4. But if we are going to do the operation, which means I'm going to make this 10 and make this 10. And these, they become 50. Okay. So what is the number of tens now? It is 3. It is failing, right? I didn't need that. But what if I told you that in spite of doing so many operations, we are okay if we do just this operation. If we just take this number. If we just take this subarray. This is a valid condition, right? Initially it was 4, now it's becoming 5. This is a valid case, right? Yes or no? Obviously it's okay. This is a better case. Exactly. How did we come up with it? Nothing else but Kadane's algorithm. See, why we were doing initially like this and why are we doing like this in this case, both are different. Okay, in the previous case we took this, but in this case we just took 2. We didn't take the remaining ones, right? Chat is slow. Oh, okay, I get it. Like a little bit of latency problem, it occurs whenever you use OBS Studio, but I'll just check. FPS is slow, but drop frames are 0. Just because the drop frames are 0, so the chat is a little bit slow. This is where the Kadane's algorithm comes, okay? Initially you got 10. The moment you get 10, let's say you're having map of 10, okay? Map of 10. The moment you, map of 10 is equal to 0 initially. The moment you get 10, you make it minus minus. This becomes minus 1. What does Kadani's algorithm tell us? The moment you find that, yeah, it's not going to work, you don't make it work. Whenever you find that it is going to be a negative number, you make it zero, right? You make it zero. So you're not going to consider this. This is bad. Now you find this 2, which means that we have to make 2 into 5 plus plus. So basically we can also come up with one other algorithm that whenever you're encountering a specific element, make map of x minus minus and map of it won't be x, let's say a of I, and map of a of I into x plus plus. Okay, so this is the basic Kadani's algorithm that we are going to perform. Now let's start with the logic. Okay, first let us consider this 10, 2, 8, 2, 4. Okay, 10, 2, 8, 2, 4. Map. Okay, you're having a few numbers. You're having, let's say, 2, 4, 5, 2, 4, 8, sorry, 10, 20, and 40. Okay, okay, clear. Now initially when we find that there is a initially all of them are zeros. Okay, initially what do we find? We find that there is a 10. So we are going to make this minus 1, and 10 into 5, that is 50. Okay, I forgot to write 50. 10 into 5 gets plus 1. This becomes 1. And the moment we find that there is a minus 1, why 20? That is because, like, I will explain you. Okay, like I'm doing it for this case now, this ai into x. So yeah, we have to go for those elements also. So this becomes minus 1, that becomes 1. Okay, now the moment it becomes minus 1, we make it 0, right? That is what Kadani's algorithm tells us. We make it 0. We are okay with it. Now we come to 2, right? Now what happens when we come to 2? We make this minus 1, this 2 minus 1, right? But this 10 plus 1, sorry, 10 plus 1. But again 2 is becoming minus 1. Kadani's algorithm tells us make it 0. Okay, remove it. Kadani's algorithm tells us make it 0 again, back to 0. So we get 1. Again we come to 8. So 8 becomes minus 1 and again becomes 0. So I'm not writing it. But 8 into 5, 40 becomes 1. We again encounter 2, which makes the 2, okay, the 2 previously, which makes this minus 1, but it recovers to 0, right? But this 10 now becomes 2. Okay, you're getting it. Now this 10 becomes 2. Now we come to 4. 4 minus 1, but obviously no effect. So 4 into 5 is 20, this becomes 1. So what is the maximum of the maps that we got? It is 2, right? For 10 we got 2, right? Hayana, 2. And what is the number of 10s that we had earlier? It was 1. So if we add both this 10 and 2 and 1, we get 3. Why does it work? Let's say. Why does it work? I will explain with the next test case that I took. This 10, 2, 10, 10, 10, 2. Okay. 10, 2, 10, 10, 10, 2. Over here, in this map, we are going to have only 3 numbers, 2, 10, and 50. Okay, this is an interesting thing. Encounter 10, make this -1, make this 1. Since it is -1, make it back to 0. Okay, encounter 2, make this -1, make this 1. 2 into 5. Okay, since, okay, I think it didn't get updated. Okay, now it got updated. Make this 1. Okay, and since you don't need the previous one, I mean this is -1, so remove it. Okay, it becomes 0. Again you get 10, make this -1, now this becomes 0. Okay, notice this thing, this becomes 0, and this becomes 2, right? This becomes 2. Again we come to 10, now this becomes -1. Okay, and this becomes 3. Okay, that becomes 3. Now since it becomes -1, so yeah, ignore it. We again have 10. Now that again becomes -1, but this becomes 4. Then we have 2, which makes this -1, but we ignore it. But this becomes 1. Now if you notice one thing very carefully, what happens throughout this? Which is the maximum? The maximum is 4. Right? 1 is not the maximum anymore. This 1, it is not the maximum anymore. Now the 4 is the maximum. And 4 comes for 50. Right? 4 comes for 50. Is there any other similar question? See, I can't, I don't know whether is there any other similar question or not, but I know that, initially to understand the Kadanes algorithm, it is a little bit difficult. Even the normal Kadanes algorithm is difficult to understand why it works, and to understand this, it becomes more difficult. I get it, but I think once you are okay with it, if you rewatch it, you'll get it. Okay. So what is it? 4. So what was earlier the number of 50 in the whole array? There was no 50, so it was 0. Now what is it? 4. 0 plus 4, 4. What is the maximum? It is 4. Okay. Clear? Ayana. Oh, okay, yeah, right. Answer will be 5. I'll tell you why. See, we are not going to find only the maximum, right? We are going to find this present element plus the maximum. So for 10, we got 1, right? For 10, we got 1. And initially the number of 10s were 1, 2, 3, 4. So 4 plus 1 is 5, which is greater than 4. Right. My mistake. 10 plus 1 is 10 plus 1, 5 is greater than that. Okay, you get it? What the formula is. How many elements that were previously there, how many elements are now there? Why we take it? Now I'll tell you why we take it like that. This is a very much arithmetic part. Okay. You have a array. Now initially you had some number of 10s, right? Initially you had some number of 10s, and they were at these positions. Okay, somewhere like this, let's say. Right? Now whenever you're going to take any of the 2's, any of them, okay, you're only going to take them if the number of 10s in between them, you're only going to take a subarray if the number of 10s is lesser than the number of 2's, right? Because the 10s that you had earlier, you're going to lose them. The 2's you're going to get after multiplying, that will become 10. Well and good enough. The tens that you had in between them, sandwiched between them, you're going to lose them. So you will only lose them when you know that the number of tens I'm losing is quite lesser than the number of twos that I'm gaining. Okay, it's like if you lose 10 rupees and you get 20 rupees, so the profit is yours. But if you lose 20 rupees and you get 10 rupees, the loss is yours. The profit is not yours. Solution of the editorial. I haven't gone through the editorial though. Editorial से जानना है तुमको. You'll get it. You'll get it. Like मैं समझा रहा हूँ ये थोड़ा टाइम देके समझाऊंगा. ठीक है. So the thing is that this array you're only going to take when the number of twos. This is the last question I did. Okay. And I had a approach for this build sum. I will go through the editorial, or maybe I won't. Okay, I won't, because I will explain this properly so that everyone understands this. So we are only going to take a sub array when the number of twos in it is greater than the number of tens in it. Initially we took this sub array, right? 2, 8, 2. We took that in this case. The example that I was explaining first. Because the number of tens in it was 0 and the number of twos was 1. Right? So we can afford to lose it. We can afford to lose a 10 even if there are any between them. What if there was 1 10? Check this question, it is same. Okay, the editorial, the explanation of the editorial is same, you mean. Now see, even if this was a 10, then also it was with benefit if we took this sub array. Why? I paste a question link. Where? Why can't I see that? It doesn't appear. Yeah, it doesn't appear. It doesn't appear on my phone also. I think I forgot to paste it. So now see, even if this was a 2 10 2, so how many sub arrays? I'll just delete this. I don't want that. So how many sub array? In this sub array, how many tens are there? Only one. How many twos are there? 2. So just a few minutes ago, I told you that you're going to only do the operation. Oops, I'm having a little bit of lagging of my video, I guess. It is going by 15 FPS. Now it is okay, 30 FPS. Now see, why would it be beneficial? So let's say if I make this 10, this becomes 50 and this becomes 10. So what is now the thing? Now the frequency. Now the frequency is nothing but 3. But earlier the frequency was 10 and 10. So this is a valid sub array. Why? Because the number of 2's is greater than the number of 10. Now how can you find out the sub array for which the difference between number of 2's and number of 10 is maximized? Right? We have to find out the place where you find the sub array where the number of 2's is greater than the number of 10's. To find that, what you are going to do is, whenever you encounter a 2, you make it minus minus. Whenever you encounter a 2, you make it minus minus, but you make the 10 plus plus. That is basically plus plus. And whenever you encounter a 10, you make it minus minus. And whenever you encounter a 2, again make 10 plus plus. Now is it okay? Like now do you get the gist? Contest. Okay, I will check it. I will check it. Now do you get like why we were doing this operation? Just to check if the number of 2's is greater than the number of 10's in the specific subarray. Whenever we encounter a 2, okay, we are going to make it minus. Whenever we encounter a 10, we make it minus minus. But whenever we encounter 2, we multiply it with 5 so that it becomes 10, and then we make it plus plus. Okay, so basically if we are only going to consider for 10, if you only consider 10, okay, so a of I is, whenever a of I is 2, we make it into x plus plus, and whenever a of I is 10, so we make 10 minus minus. Okay, so that is the reason, that is the thing that we do to find out if the number of 2's is greater than the number of 10's. And that is only possible if the answer, if the map, that specific map is going to give us a positive number, then only it is greater or greater than equal to, even greater than equal to works. Okay, then only it is equal. I mean, then only it is a valid case. Okay, if you want me to explain with some other example, I will use, there was one of the test cases 6262. Okay, 6262, and the value of x was 3. Okay, now let's say, why do we use that formula if you want to know? Let's say for this, I'm going to consider this, only this sub array. Okay, how many 2's are there? 2. How many 6 are there? 1. Which is greater, 2 or 6? 2 is greater, go for it. Right? 2 is greater, go for it. But if we took this, the whole sub array, how many 2's are there? 2. How many 6 are there? 2. So what is the absolute difference? 0. So which is better? You take 2 2's and 1 6, or you take 2 6 and 2 2's? It's like you give 20 rupees. Whenever you're taking a 6, you give that money. You give your money. And whenever you're taking a 2, you take your money. So is it better that you give 10 rupees twice and take 10 rupees twice? Or is it better you give 10 rupees once and take 10 rupees twice? Obviously, second case is better. Right? So that is the reason we take this. Or we can also take this. Just this. Because if you're giving 10 rupees twice, if you're giving 10 rupees once and taking 10 rupees twice, you're making a profit of 10 rupees. But if you're just taking 10 rupees once, then also you're making a profit of 10 rupees. So this is also a good thing. So either you make this 6, so the frequency is going to be 6, the frequency is going to be 3, or you make this thing into 3. 3 into 6 is 80. Then also you can find that the number of 6's is 3. Okay, do you get it? Like the case of profit and loss. Now what we are going to do is just to make it more simplified, not to to reduce the time complexity, we are using the map. Because what a map does is, whenever we are going to consider this, or let's say for now we are going to consider this. Okay, this sub array. Let's say this is not the optimal solution, but let's say we are doing it. Okay, let's say we are doing this. Now if we take this sub array, how many total 6's are there? 2, right? Total there are 2 6's. Among which, what is the effect that this sub array is having on it? It is going to have an effect of 0. Sorry, this is 1, right? There is only 1 6. Sorry, there is 2 6's. Okay, right? But what is the effect that this 2 and 6 is having on it? It is 0, right? It is nothing but 0. Because this 2 becomes 6 and this 6 becomes something else. But what if I told you, like you were taking, okay, so let's say, yeah, this. Which means, how many 6 are you going to take? You're going to take 2 6's, right? Since this was having a negative effect, this was having a neutralizing effect, that is 0. So your answer is 2 plus 0. Why? because you may have taken out 1 6, but you have also contributed 1 6. Is it clear? You took out 1 6 from all the number of sixes, you took out 1 6, but you also contributed 1 6. So it is most important to find out how many you contributed and how many you took out. That is what all matters about. Okay? If you want me to go through the mapping, the map concept, 6 2 6 2, the map will look like somewhat like this: 2 6 and 18. You find, okay, it is 0 0 0. You find that 6 is having the value of, let's say, 6 and 18, right? So 6 becomes -1, 18 becomes 1, but since it is -1, so you make it 0, it doesn't matter. Then you encounter 2, -1, make it 1, 6, again make it -1, that is 0, and make this 2, and again you encounter 2, so make this -1 and make this 1, right? So what is the total effect? This is going to be 0, okay? So what number of 2's initially was 2. Number of 2's now is 0. 2 plus 0, 2. What is the maximum value that 6 got? 1, right? The maximum value that 6 got at any specific position was 1. So what is 1 plus the number of 6 that we had earlier? 2, that is 3. Okay? And for 18, obviously we never had any 18 only, but we will be having two 18s. When can we have it? If we are going to utilize all the elements of the array, if we make all of them into 3, so you will get 2. Okay, you will get 2, but that is not a valid condition. So that is 6, which is going to have the frequency of 3. Is it clear? Even if it is not clear, I will walk you through the code. Okay. See what we have done. We are taking two maps. One map is map 2 just to count the number of elements that we are having. This is the frequency map. Okay. This is nothing but the frequency map. We have it. After that, we do the operation AR of I into x plus plus AR of I minus minus. If at any position you find that AR of I is getting in negative, you make it 0. Okay, that is what Kadane tells us. Answer is maximum of map of 1 of this plus map of 2 of this. That is the number of element that was initially in it and the effect that it has on it. Since we are manipulating both of them, AR of I into x as well as AR of I, okay, so we also do for AR of I also this thing, but I don't think this was necessary. Even without this also it will work. Okay, then you print the answer. Very simple code. If you want to go through the editorial, okay, we did something really cool. Okay, you want to know what we did cool? In this case we are going for big O n approach, right? We did it in big O n approach, and Codechef's official solution is in big O n log n. Codechef has come up with the code for big O n log n, but we have done it in big O n. Okay, it is worst case scenario because we are using unordered map, right? The log n map is like if you're using normal ordered map. in unordered map, in worst case scenario, when the hash code of all the values get as close to same, then only we get the collision and then only we get the login. Okay, otherwise we don't get it. They're doing merge sort. Okay, so that's the reason I think they're taking it in login. Okay, no. My mistake, my mistake. They're also considering this login for the map thing. Okay, they're also considering this for the map. So yeah, in login only. But they have a different approach. They have a completely different approach. And this approach is maybe easy, maybe not. Okay, they have a completely different approach. This is the testers code. Like the testers, they work so much on just writing one code. Like they have to assert the whole thing. I get it. I get it. I get it. Okay. So is it clear? Is everything clear with you guys? Yeah. Map takes login time. Yeah. They are also going to consider that. But it usually doesn't take that time. Okay. This login can be ignored well enough. Because I think it was 10 to the power 6, right? Okay, 10 to the 5. Yeah. Login also works, right? But remember one thing, like if you're using ordered map, then the average case is also login. But if you're using unordered map, then the worst case scenario is login. Because I don't know how many of you know about Java, but in Java what happens is there's a hash map, okay, which is having key and values. Yeah, exactly. Because you're having key and values, okay. It can't be ignored because value goes exactly. I get it. 10 to the power 9. That's the reason. If it was not like that, so it would be big one, right? Now, if you're having k and v, now this k, the hashing of this k, it completely depends upon some algorithm. Now, since it is going till 10 to the power 9, and if we make this k as as it is k, we can't have it because 10 to the power 9 is going to give you a memory limit exceeded. So yeah, it will be 10 to the power 9 by 22222. So yeah, 3 times, which means that at max there will be 10 to the power 9 keys. But if we are going to divide it equally, we are going to come up with 3 keys. So that is basically a log of 10, like very less. Like I know you can't ignore it, but yeah, not that much. So yeah, it is well within our limit. Okay. Build some I won't be explaining. Let's quickly go with the rating of the problems. We will have 3 divisions only, okay, today. easy, medium, hard. The first problem was easy. Second problem was, what was the second problem? Alternate, okay. Alternate was like, okay, we can go for medium. But actually if we go this for medium, yeah, we can go for this as medium. C was somewhere over here. D was hard. And the other ones were, I don't know. Okay. So for E2, F, it was quite hard. Okay. So yeah, that's it from my side. Thank you guys for joining. Have a good night. Bye.